Hi, I'm Karthikeyan. We are going to do 2D shell mesh and 3D hexa mesh by using HyperMesh software. I'm choosing a wall mounting part in here. I'm going to click review for this part and I'm going to isolate which the part I want. I'm going to delete unwanted parts, and after that I'm going to do surface repair by checking is there any errors. There are zero errors. After that I'm going to do feature options. By clicking fillet I'm going to remove all the parts, and after clicking holes I'm going to delete all the holes. After that, by using a fillet option, I am going to remove the fillet surfaces in the mounted moon of the two parts, so that the mesh flow according to the part will be easier to me, and the mesh flow will be very good. By removing all the fillets from the mounted part, the part will look nicer on the both mounted areas. After that, I'm going to set parameter as crash 2mm and criteria as crash 2mm, so the element size will be 2mm. After that, I'm going to do bit mesh, which is a shell mesh, by extracting the mid surface. By selecting the whole part, I'm going to mesh the part. After meshing, I'm going to rebuild the entire element to get the proper mesh flow by using flow guidelines, and also I'm going to use various edit element options like smooth and move elements. The meshing process is going on. The part is meshed properly. After that, I'm going to rebuild this part by using a flow guidelines. I'm going to place the guidelines vertical and horizontal to get a proper flow according to mine. After that, I'm selecting the whole element. I'm going to rebuild it again. I'm going to give rebuild option as many times until the patches are worked really well. And by giving the rebuild option again and again, the unwanted and white patches which is displayed on the part will get reduced slowly. After that, by clicking on the smooth operation, I'm going to select the patchy areas which have not been rebuilt properly. By clicking on the smooth operation, it will rebuild again. After giving on the mid surface area, I'm going to mid surface the surface of the component by clicking on the mid surface. This mid surface has been given to check whether bit mesh is projected properly to the mid surface. So now there is no overlapping of the elements, so the projected mid surface is good. After that, I'm going to check the quality. The element quality should be less than 2%, and it is passing the element quality check. So there is no element error. It is less than a 2%. After that, I'm going to map the thickness by sourcing the solid and targeting the elements. After that, after applying thickness, I'm going to give some varying colors to differentiate the thickness. The thickness part is going on. Now I am going to give various colors. We can see the thickness has been projected in the various line. The advantage of bit mesh is to create a meshing in the center part of the part and projecting the thickness in the upward and downward direction. So the mesh flow will be easier, and there will be a less time consumed. We are now going to see a 3D shell mesh, 3D hexa mesh by doing a mappable thing. I'm going to check for the surface repair. After that, I'm going to go for D feature. By removing the fillets, the mesh flow will be very good for me. I'm going to use the mappable command from the automatic window. After that, I'm going to split the component by using split command and line by projecting the plane as respective as mine. And I'm going to map the second part by using the source as solid and the splitting by line and map the whole part. And I'm going to hide the parts, and I'm going to do the following procedure using the plane. I'm going to map it using a plane. The mapping process is going on. So in this mapping, by using mappable product, we can reduce the time. We can also map the complex shape. So instead of doing a total thin solid hexa mesh, we can use this mappable tool, so which reduces the time of computing. So I am projecting the plane rightwards, and the one part is mapped. I'm going to map the second part, and the entire component is mapped. I'm going to show all the component. I'm going to, using under 3D tool, I'm going to map using the mesh as a 2 mm criteria. After that, by clicking on the mesh density, I'm going to review it. To check the mappable, to check the hexa mesh, we can go on a cross section view, and I'm going to vary the color to differentiate how the hexa mesh has happened really by giving a color. So I have given a separate color for the hexa mesh, and there will be hexa elements in that, and the hexa is properly done. After I'm going to give a representation by clicking on the save, converting CAD into thin solid and representing the study revisions. After that, I'm going to update this representation on the part. By updating the representation, the part will get represented by a hexa thin solid 2 mm. We can scroll it on the bar. After that, I'm going to check the quality of the element which have been created by machine by clicking on the element quality to under automatic section, and we can check as there is less than the criteria, it is goodly saved.